All right, we're live.
Great. All right. Good morning, everybody. Welcome to Friday, day 5 of the 2021 Pennsylvania Virtual Turfgrass Conference. We glad that you've been here all week with us. It's been a good week so far. We've done pretty well. Just as a reminder, for people that are unfamiliar, if you're needing pesticide credits, if you would please in the chat window. If you would please put the name as it appears on your card, your state of residence, and your certification number. So in the chat number down there in the chat window down at the bottom, please put your name, state of residence, and your certification number. And this way we can get you credit for those. I also have GCS AA credits. I will go ahead and post the GCS AA code at the end of the last talk, and I'll get that in there posted for you, so that you can also get credit for Golf Course Superintendents Association of America credits as well.
Okay, so the lineup for today, we have 3 speakers. We have Brad Jacobowski, Jenny Crist, and Pete Lanscoot. And the first up is going to be Brad. So let me give that introduction and start his talk. Okay, Brad has been involved with the green industry for over 30 years. Working with residential, commercial, golf course, and sports field areas. Currently, he's an instructor in plant science department and a PhD candidate at Penn State University. Previously, he directed the 2-year sports turf management program for the University of Nebraska and taught meteorology and environmental science for Doane University in Nebraska. Brad's currently teaching multiple online and traditional irrigation and turfgrass management courses in the 2- and 4-year Penn State degree programs. So with that, I will get your presentation started, Brad.
Greetings, everyone, and welcome to today's version of the 2021 PTC Virtual Turfgrass Conference. And today, I'm here to talk to you about weather apps. My name is Brad Jacobowski, and I'm here with the Penn State Turfgrass Department. And we're going to talk a little bit about making weather-based decisions and how those things impact us on a daily basis. So let's go ahead and let's get started. Today, we're going to be talking about things that impact us on a daily basis. And as turfgrass managers, we are constantly checking the weather. It influences our actions on a daily basis. And I'm here to talk to you a little bit about some of the different apps that are available, some of the functionalities that can be available to us and that may help us make much better daily decisions on projects, tournaments, whatever those things might be. So my goals for you today then are to have a better understanding of weather conditions that affect us or may affect us, okay, to gain a new perspective on any kind of weather information that we may already be looking at on a daily basis, and also then to be able to synthesize that information and making the best weather-based management decisions possible. So these days there is so much available for us, and that would include weather apps on our tablets, on our phones, computers, even handheld devices that we might use to help us determine all that information. There is so much out there, and so that we're blessed with a plethora of weather-based information for us out there that's based off of technology. However, even with all of that information, it's still important to look up every once in a while and see what the sky is actually telling us. And like on a day like this in here, what we see is a sky full of aircraft contrails. And we might not think much of it, but actually these aircraft contrails can tell us a story. And all of these are telling us that in the upper atmosphere, there is a lot of moisture up there. And so if there is some kind of an instability or some type of a lifting mechanism that's coming through the area and there's already a lot of moisture up there, this could tell us that, you know what, if we have something coming through, significant weather could then be in our short-term forecast. compared to if we were planning on, let's say, reworking some tee boxes or whatever it might be, and we see a day like this where we've got a couple of aircraft flying over, and these are the contrails that they're leaving. And if we saw those, we'd think, gosh, you know what? That's telling us that the upper atmosphere is pretty dry. So even if we get some kind of instability or mixing or whatever on a particular day like this, chances are not much is going to happen because the upper atmosphere is not loaded with very much moisture, and we may have a good opportunity to get any kind of projects finished for us. So looking up can make a huge difference. Or something like this, if it's coming into the afternoon and we see a day like this with a lot of vertical movement, this is telling us there's a lot of moisture in the atmosphere, and we're also getting a lot of instability, telling us that we could be having some significant weather to impact us as we're trying to get some work done. So why do we monitor the weather? Well, to answer some of the following questions. One of them might be, how do I plan today's maintenance? We're always trying to figure that one out. You know, who's going to be cut? You know, can we get cuts cut, greens, you know, morning setup, and all of those types of things can make a huge difference for us. And so these are some of the things, one of the questions that we would normally do. And this is going to impact us on a daily basis. And so we're always checking the weather forecast to see what can we do with that. Or should or can I spray today? You know, this type of a thing. So all of a sudden, you know, should I be scouting a little bit more closely for particular diseases, or can I spray? If I know that I should, can I, based on the weather conditions that I've got? Also, is it time to irrigate? All of these things then can help us by knowing a little bit more about what we're looking at on our weather apps or on our websites or whatever it might be. All of this can help us make much better timed and more useful decisions. One of the things that we look at quite often then is weather radar. And I just wanted to briefly kind of describe to you the inner workings of weather radar. And what it is then is with the new dual pulse, or the kind of the dual imaging weather radar that they have out there these days, is think of it as like a 450,000 watt microwave oven or a microwave signal. And they send out a vertical and a horizontal signal. And the signals then bounce off of water droplets, and the larger the water droplets, the larger the signal that comes back to the receiver. And this is what tells us, do we have light rain? Do we have heavy rain? Do we have potential hail? All of those types of things. So like a 20 decibel signal might be like your light greens or your blues on a weather radar image, and it's going to be just very light rain. Where when they get into those pinks and reds and some of those heavier colors like that, then something like that might be a 60 to 65 decibel return, telling us we're going to have very heavy rain or even potential hail. And so just knowing a little bit more about the radar and the energy pulses that are being sent out and being received can help us. Another thing to look at, whether we're looking online or on our phones for whatever it might be, when you're looking at your weather radar and you're trying to make a decision, take a look at what you're seeing here and double check. Is it a base image, base reflectivity image, or is it a composite reflectivity image? And these then can make a huge difference on helping us to decide, real time, what kind of decisions should we be making. And this particular image here is a base reflectivity image, and you can kind of see what this one looks like. And we'll take a look at what a composite image looks like. So a base reflectivity image is just one sweep of the radar beam. And so you're only getting one little cross section of a particular storm. And the farther it gets away, the less accurate you might actually be able to see. These radars reach out to about 140 miles. And beyond that, it's important then, if you need to reach out a little bit farther, is to find the neighboring radar station and get an image from them. But it just base reflectivity gives you one sweep of the radar beam. So here's our base reflectivity image here. Okay, and this is also on our phones. This is maybe what it looks like. And it's important to then look down somewhere on your phone where it may be saying base reflectivity tilt 1 or tilt 2, tilt 3, just the different tilts of that base of that radar signal that's being sent out. And so this is what you're seeing here. So this is a base reflectivity image. Okay, where a composite reflectivity image is where they take multiple sweeps of that radar and they digitally stitch them together to get you a much more significant image, composite image of everything that's going on within that particular storm. And so here's your composite reflectivity image of that same system that we saw with the other one, compared to this one here. So you can see a big difference between a composite reflectivity image and a base reflectivity image. This one in here even has a little bit of extra pink, which is telling us that we could have potential hail, or up to a 16 inch per hour rain rate here, where we didn't necessarily see that with a base reflectivity image. And so knowing what you're looking at when you're looking at radar can make a huge difference, and kind of look through those. And so make sure that you're kind of taking a closer look, or a more knowledgeable look at the different types of radar and the different types of radar images that you're seeing. Okay, and so like with this one here, you can kind of see that you've got a whole bunch of different products with this particular radar product. And so you've got super res reflectivity. It's going to give you really nice graphics, but it may only give you one tilt at a time. Here's your base reflectivity compared to composite reflectivity. So sometimes they may give you super res, but it may only be a single tilt. So you'll also want to look at the composite reflectivity image and get a total image of that entire storm. Another thing to look at then, and a couple of summers ago, I was mowing fairways at a golf course, and I was always kind of keeping track with the golf course superintendent. And oftentimes, one of the things that he would look at when trying to make plans was cloud heights, or in this case here, echo tops. So this particular weather app is Radar Scope, and it's a very good radar app, something that you might want to take a look at. And one of the things that they look at then is echo tops, or cloud heights. The echo tops, how tall are these clouds? The taller the clouds, the stronger the image. And so you've got these lighter blues telling us that it might only be like a 13,000 foot height clouds, where these greens and other ones here might be telling us it's 20 to 30 to 40,000 feet, telling us much stronger image, or a much stronger system coming through the area. And so these echo tops, then the taller the clouds, the stronger the updrafts, which may tell us that there's large hail is more likely, and those types of things. So echo tops or cloud heights can be another thing to help you on making your decisions. Another one then here is vertically integrated liquid. How much water is distributed throughout that storm. Taller updrafts then tend to have higher values of vertically integrated liquid. That liquid is being integrated vertically throughout the entire storm, telling us that there's a lot of updraft, and telling us that it could be a much more disruptive storm with potential hail, and could then also have an impact on whether you've got a tournament scheduled, or you've got a maintenance project or something that you're trying to finish. Knowing this one here may also tell you the strength of the storm, or the strength of the system that's coming through the area. Vertically integrated liquid is a good one to look at. Another one, digital storm total accumulation. How much actual water can we expect out of this particular system that's coming through an area? You can kind of see when you kind of go over here to the pinks, with this area here, they're predicting about a little over an inch of rain accumulation over some of these areas. So if you're trying to schedule a project, or let's say you're trying to make a game time decision, and are you going to call the game, are you going to pull the tarps, those types of things, all of this then can make a huge difference. So digital storm total accumulation can also then be another one of those tools to be able to use while you're trying to make some real-time weather-based decisions. So how do I plan my maintenance today? Other things to look at. Another one then here would be this particular website. This is the National Weather Service, or www.weather.gov, and looking at the forecast. One of the things to look at would be the hourly weather forecast over here. And it's a very nice one to be able to look at. It gives you an hour by hour account, or it's a kind of a visual to see what's going on with the weather and winds and a whole bunch of different things here. Or another thing to look at then while you're on the weather.gov site that's somewhat unique for them is the forecast discussion. You click on the forecast discussion, and this gives you a synopsis of what the forecasters were actually thinking about when they were putting together their weather forecast. And so it really gives you a much more in-depth or in detail explanation of what's going on with that weather, and how to make your management decisions. And so the forecast discussion can be a very, very important tool to help you in making some better decisions. Another site then, Weather Channel, or weather.com, instead of weather.gov, weather.com. And one of the things that's always good to look at then here would be the surface weather analysis maps. And so what you could do then is you go click over here on this hamburger. Over here, go to Classic Weather Maps, click on that, and it'll give you your classic surface map analyses. And then we can kind of talk about here about the different types of frontal systems and pressure systems that are coming through an area to help you make better decisions. And so we can talk about fronts, understanding the different types of fronts. The two that we deal with most often then are your cold fronts, or the ones with little icicles, and the warm fronts here with little warm bubbles here like this, little red bubbles like that. So warm fronts and cold fronts. Remember, a cold front then, or a front, the front is the actual leading edge of a large body of air coming in behind it. So here in central Pennsylvania, they got this cold front coming through. So on this side, we've got warm air coming up from the south there with this warm front here. So on this side of the fronts, nice warmer conditions, winds out of the south. Well, then today we got a cold front coming through with winds shifting to the northwest, west, northwest. And that's what this air here is bringing in here. So then they're going to have some turbulent weather coming through this area here in a very short period of time, just based on what this weather map is showing us here. And you can also see then there's going to be a second cold front coming through. So we've got colder air and then much more frigid or much more colder air coming following this front, maybe in another day or so. So these are some of the things that you can kind of take a look at when you're looking at these types of things, is, you know, what's happening with this warm front, what kind of air is behind it, what kind of air is behind this. All of those things can make a huge difference. So remember, with a cold front, you're going to have much more vertical type of cloud formation that you're going to be looking at in the sky, and you're going to have much more disruptive weather for a short period of time, let's say heavy rains and thunderstorms for a few hours here, compared to a warm front, which would be different, where maybe instead of a few hours of disruption, you may have a few days of some different types of weather that way. So a cold front then is going to bring us more turbulent, short-term, heavy rain, heavy weather here. Okay, so question for you then, situational analysis. You've installed a 4-inch sand cap and you're putting down a large sodding project. Maybe you got some tee boxes that you want to get done. They've announced a cold front coming in the afternoon, bringing rain with it. And from 12 to 1, let's say the guys were at lunch, and then normally they quit at 3 p.m. and you've got a cold front coming through. You know, what do you do here? Do you try to work through and get that sod down before the cold front comes through? Do you tarp it? A number of those types of things, and knowing what kind of weather normally comes with a cold front will help you make these decisions. You're going to have much more heavy rain, turbulent weather, so maybe you have a better chance of rain, of that sand washing, so you might have to tarp it or make some much more radical decisions. Okay, so those types of things can help you when you're making decisions like that. Compared to a warm front, which is going to bring in you more layered overcast days, where you may have, let's say, light to moderate rain for a couple of 2-3 days coming through the area. And this might have a totally different thing where it's just light rain, mist, kind of annoying that way, and wouldn't be quite as tumultuous as a cold front coming through. And so with that same situation, how would you change this? Let's say you've got warm front rains coming through the area with that same 4-inch sand cap. What do you do with this one? Do you just have the crew, you know what, let's work on through this one, or you just say, you know what, it's not going to be that bad, we can hold off and just kind of keep the sod covered, and then maybe do this tomorrow if we're going to have too much of that. So this would be something to kind of consider when you're looking at that. You know, what type of front is coming through, what type of rain, and being able to make decisions based off of that. Pressure systems. Remember, with low pressure centers coming through, you're going to have turbulent, uplifting type of weather, mostly type of rain. With high pressure, you're going to have more cloudless days, pleasant weather, more fair weather with high pressure coming into the area. That will also help you make some decisions based on that. So weather, it's all about water and heat. Water is the fuel that makes this weather go. Heat is like the spark plug for a car. It kind of keeps that engine running and keeps that stuff moving along. So it's all about those and what happens with that water and heat changes as it goes on. Okay, this one here then. So then when, you know, like if we have knowing the ways that energy is transformed or converted from one form to the other makes a huge difference. Like when we have an ice cube, when we're holding an ice cube in our hand and it feels cold, what's happening is heat then is being transferred from our hand to the ice cube, causing the ice cube to melt. Okay? And so there's so many calories per gram that's happening with that. When water evaporates, like when we syringe our turf, okay, there's a thin layer of water on those grass blades, and as that water evaporates it's pulling heat away from the grass blades, and those grass blades then have a tendency then to cool from the water that's from the heat that's being pulled away from them as the water evaporates. And so those are some of the things, just by us knowing what happens when water changes form, can be a huge tool for us. So with this one here, as that water evaporates, with this situation here, we had a canopy of a canopy temperature of about 103 degrees on a 90-degree day. We syringe the greens, maybe one circulation of the heads. We go back 5 minutes later and we see almost a 20-degree drop in temperatures from the start to the finish here. And so just by knowing some of these things can make a huge difference. So also, warm air, remember that warm air holds on to a lot of water in vapor form compared to cold air. It just can't keep it juggled very well. And so it's going to drop it out, and we're going to see water form as liquid or solids, as a frost or as dew, something like that when water is colder than when it's warmer. And that's kind of what this little image is showing us here. So what this leads us into then is relative humidity, things that we look at on a daily basis. Relative humidity, remember, relative humidity is just a ratio between how much water the air can hold compared to how much it actually is. There is there. And so normally you will hear it then referred to as, we have 50% relative humidity, telling us that the air is 50% full of water. Okay, but it doesn't actually tell us how much moisture, it doesn't really tell us how humid it is. It just tells us how much water the air can hold compared to what's actually there. So remember, relative humidity then changes with temperature. This line here, this is temperature. And as we can kind of see on this particular day, as temperatures increase and decrease, relative humidity then does the opposite. So there's an inverse relationship between these two. And so relative humidity is always changing compared to dew point, where dew point then is the temperature at which dew, clouds, frost, all of these things form, so that when you have the air temperature and the dew point temperature meet, and then you have 100% relative humidity, then that's when dew starts to form. So when air temp and the dew point temp meet, are the same here, then that's when you're going to have dew or frost or something form. So when you have 100% relative humidity, that's when we have kind of dew forming, or the dew point temperature is met. Okay, so then just some rules of thumb. When you have dew points, let's say in excess of about 65 to 80, that's when there's a lot of moisture in the air. And this is when you're really it's important to track this for potential disease pressures and things like that, especially when the temperatures start getting up in these areas here and you've got dew points in the 60s and above. That's when it's very important to do that. If you have dew points under 10, it's so dry that even snow has a hard time forming at that point. Okay, so those are some of the things to kind of keep an eye on when you're talking about dew point. Okay, so this little image here shows us we have 100% relative humidity here and 100% relative humidity here. However, the difference, we have a dew point of 50 and a dew point of -6. So the air is saturated, something might form, but there's so dry air that not much may happen. Where this one here, you've got a lot more moisture in the air. So you're definitely going to have some kind of dew form and potential situations with this one here. Okay, so if we only saw relative humidity, would we have a concern? We see, well, we're in the 90s, all of a sudden it drops into the 60s. Well, that seems like a pretty pleasant day for us here. Not too much of a problem. However, if we look at the whole picture, what we see here then is here's temperature, here's dew point, here's relative humidity. And so what we're looking at here then is that we see that we've got temperatures in the 50s and they drop all the way down into almost the single digits here within a 2-day period. The dew point, which is a measure of moisture, then is showing us we had comfortable moisture levels dropping down into the single digits, saying that we had air dry out significantly here. Wow, this is a very significant change with a minor change in relative humidity here. Okay, so what if it's October and we have some new seedlings popping and this occurs? What do we do? What do we do to protect that? All of a sudden, we've got some very, very delicate plantings that have come up. They're just popping up. And if we had a day like this or a couple of days like this happening, boy, could we have some serious problems like this. And so we need to figure out what do we do to protect our new seedlings coming up so that we don't have them desiccate or die out or whatever it might be. So by knowing these things can make a huge difference for us. Okay, overnight conditions, what can we expect here? We kind of see on this particular day, we've got temperature and dew point meeting. And so chances are we're going to have heavy dew. So we may have a lot of clumping with the mowers. and things like this on a particular day like this, where on the next day over here on Wednesday, the air temperature and the dew point temperature aren't very close. And so chances are probably no dew, and it would be, and no frost as well. So we're going to be a much easier day to mow here. So one thing to kind of be able to keep eye on, and if we saw some steam fog coming up from the water and we knew the air temperature was 37 degrees, chances are we would also know then that the dew point was also 37 degrees if we saw something like this. Okay, frost management. So this is where it's important to always be calibrating yourself. Let's say we're looking at there and we're trying to figure out if we're going to have frost problems or a frost delay. Well, right now, let's say if that's at 6 or 7 a.m., we have a 33-degree air temp and a 28-degree dew point, but we're still getting frost forming in these areas here. Well, it's just a matter of remember that you're getting these readings from an airport, and those readings are being taken about 5 to 6 feet in the air here, where it might be a lot different from at the grass or the canopy level here. So it's always important to constantly calibrate what you're reading, what you're seeing with what you have going on at your home location. So that's why it's also important then to keep an eye on the 3-day history. You can always then track this, and you can use it to help with your spraying records or just seeing what the tendencies are. You know what, I had frost yesterday morning at 6 a.m. and these are the conditions I had. So anytime I get these two getting close together, I need to be careful and plan accordingly. So will we have frost this weekend? Maybe not here. We got really dry air and they're not really that close together, so no, but here, chances are we're probably going to have a frost delay in this location here, or a frost situation here. This one here may have a serious frost situation here. However, we got some strong winds that might combat that, but this would show us, boy, we could have serious frost happening on those 2 particular days. So should or can I spray today? Well, which day has a greater need for has a greater disease potential? What we have here, we have temperatures in the upper 90s with a dew point of 70, so it's hot and humid, compared to on this day here, it's 93, so hot and with dew points in the teens, hot and dry. And so in this case here, we might have a much greater disease potential here than we do here. However, in this location here, if we put down a syringe cycle, this would have a tendency to really cool the grasses much more effectively on a day like this where that water wouldn't evaporate very well. And so you can kind of see some things there to kind of keep an eye on when you're looking at disease potentials. Also, is it, you know, should we spray or can we spray? Are we having problems with potential inversions? Are we spraying some kind of an ester-based product? And if that's the case, that oftentimes may have a tendency to translocate or move. And so if you have a day like this, you're going to have nice mixing in the atmosphere telling us that it would be much safer to spray on a day like this compared to if we have inversions like this, where if something then volatilizes, it have a tendency to then move laterally along the locations here and give you problems there. And so those are some of the things to kind of look at. So should I spray and can I spray would be a couple of things to kind of look at there. So is it time to irrigate? So which day would have a greater need for irrigation? On Monday, June 11th, today's high will be 96 with 15-mile-an-hour winds out of the south. Friday, June 15th, highs will be 93 with 6-mile-an-hour winds out of the southwest. And so with this one here, we would kind of be thinking, well, based on this information, chances are Monday would need to have a greater need for irrigation. And these were those same plots that we had seen before. And as you can see here, with this one here, we're looking at, we've got hot conditions with humid, high dew points. And so especially with this situation here, we definitely want to be scouting for mycelium or some kind of a disease pressure over here because we've got extended leaf wetness. And chances are we probably wouldn't be needing to irrigate nearly as much on these days here as we would down on these days here, where we have, again, hot conditions, but very, very dry. And so you're going to have ET rates that are going to be extremely high. And remember, on a day like this, if you put down a syringe cycle, this water is going to evaporate very rapidly and will also provide you some evaporative cooling on a day like this, compared to if you try to syringe on a day like this, that water isn't going to evaporate very well at all. And will probably just sit there much longer than it would here. You're not going to see any kind of evaporative benefits to your cooling process on a day like this. And so these are some of the things that you would want to kind of keep an eye on with those. Okay, so as a recap, Also, again, find the software apps that best fit your situation. There are a number of them out there. Radar, My Radar, Radar Scope is a good one. Weatherbug, Dark Skies. There's a whole number of good apps out there. Also, weather websites, www.weather.gov, weather.com, AccuWeather, Weather Underground. There's a whole number of good ones to be able to look at for that. Also, don't forget to look up. Let's see what those skies are doing and kind of showing you what they're doing and how can you calibrate your eyes and what you feel with what you're also reading on your weather apps. Next, then on there, understand the differences and the relationships between relative humidity and dew point. Remember, with this one here, relative humidity is going to fluctuate on a day-by-day basis. And so just because you have 100% relative humidity may not necessarily tell you that you're going to have some serious problems, or vice versa. So it's always important to see what's the relationship between the air temperature, dew point temperature, and relative humidity. Use those three all together to be able to help you to make much better decisions on, do I have disease pressures? Do I need to irrigate? Can I spray? Should I spray? A whole bunch of different things like that. Also then from there, then be sure to calibrate your information with your particular situation. You know, am I worried about what time to bring the crew in because we're going to have frost delays? Or do we need to be concerned about heavy dew the next couple of days? So do we need to make sure that when we're out there, do we need to whip greens or whatever it might be? So all of those types of things. Are we going to have extended leaf wetness? Do I need to make sure that the part of the crew that's doing course setup, do we need to make sure you're taking an extra close look then at what's happening with scouting? Do you see any mycelium out there? Do you see any spotting or anything like that? Any types of things like that can all make a huge difference for you. So always calibrate your eyes and everything else with what you're seeing there. Makes a huge difference. Okay, so overall then, knowing the little things will help you avert disaster. And if you have any questions whatsoever on this talk or anything like that, please don't hesitate to reach out and contact me. Again, my name is Brad Jacobowski. I'm with the Penn State Turfgrass Department, and my email address is brj8@psu.edu. And I hope you have a great day, and I hope you enjoyed this presentation.
Okay. I don't know what happened there. We're still playing part of your talk at the end. Right, I didn't look at the questions. I don't know if there were any for you or not, but
I was kind of looking through. I didn't see, so far so good. Doesn't look like we have any more login issues at this point. Things are looking pretty good there anyway. So
I answered several emails for people and sent information out, and it looks like we're pretty decent in terms of the people. Maybe just a reminder about how they can submit pesticide.
Yes, thanks, John. So again, if you're fresh to the talks, to receive pest ed credits for this one here, be sure to include the name as it appears on your ID card, on your certification card, the state that you're from, and also your certification number. If you could keep those in there, if you could put those in the chat window, that would be great. So again, your name, state of residence, and your certification number would be great. And again, I do have GCSAA credits. I did post the previous 4 days of numbers there, and I will also then post today's at the end of our last talk following Pete's talk today. So thanks.
Okay, thanks, Brad. Great presentation. Thanks for everybody that commented the same. I'll introduce our next speaker. Jenny Crist received a Bachelor of Science degree in Ag Science from Penn State and a Master of Science degree in Agronomy from Iowa State. She's employed with Penn State's Extension Pesticide Education Program as an extension educator. She's also involved with K through 12 education and outreach, pesticide safety, presentations, and other related educational activities. She's a certified public pesticide applicator, and prior to working for the Pesticide Education Program, she spent 2 years as a Penn State Extension Nutrient Management Specialist and 4 years working for conservation districts as an agricultural conservation specialist. She also has experience with pesticide sales, research, and safety, and that's what she's going to be talking about today. So let me hide my
certification program. And today I'm going to talk to you about pesticide exposure. So when we talk about pesticide exposure, we want to talk about the hazard of a pesticide product. And to determine the hazard, we really need to focus on two factors: the toxicity of the pesticide product and your chances of exposure to that product. So hazard is defined as the risk or potential for harm, and toxicity is going to be defined as the capacity of a pesticide to cause harm. So exposure is going to be the opportunity for that pesticide to contact or enter the body. Something else we need to think about when we talk about pesticide exposure is the length of time that the exposure lasted and what area of the body this exposure occurred on. So what kind of exposures are there? There is direct pesticide exposure, and this is going to be when you have contact with the pesticide itself, meaning the formulation, the concentrated version, or even a slightly diluted version of the pesticide product, but it's the product itself. So this is going to happen during mixing or loading, when you're applying that pesticide, when you're maybe doing equipment maintenance, or you're disposing of, storing, or you are handling the spill. So again, direct exposure is when you come in contact with the pesticide itself, whether it is diluted in a spray tank mixture or it's the actual concentrated formula straight from the container, okay? And then the other type of exposure is called indirect or secondary exposure. And this is going to be when residues are transferred from your application equipment, your PPE, your application site, or if you come in contact with residues when you are laundering work clothes that were used for pesticide application. So how do pesticides enter the body? Exposures are going to occur when pesticides get into or onto our body through the skin, also known as dermal, through the eyes, also known as ocular, through the lungs, also known as inhalation. So you breathe that in through your nose or your mouth into your lungs. And then finally through the mouth, or also called orally. So that's the difference between inhalation and oral, is where the product ends up. So inhalation is going to end up in the lungs, through our respiratory system, and orally is going to end up in our digestive system, so through our esophagus and down into our stomach. Dermal exposure is one of the most common types of pesticide exposure, and pesticides are going to be absorbed at different rates through different parts of the body. Our body parts will absorb pesticides differently. Areas with thinner skin are going to absorb higher levels of pesticide much quicker. And then your hands and your forearms are going to receive the most exposure. And so when we talk about the different body parts, these are areas where exposure is very high. So the highest area is the genital region, where 100% of any pesticide that's going to come in contact with that skin is going to be absorbed. Next is the ear canal, which is very surprising, but kind of not really if you think about the actual construction of the ear canal. There's not much separating the inner and the outer ear. But the ear canal, almost 50% of any product that comes in contact with that's going to be absorbed. The forehead is 36.3% absorption rate. And then from there we go down with our scalp being less, our abdomen being even less, our feet at only 13.6%, and then finally our palms and our forearms are the least, so palms being 11.8 and forearms being 8.6. So thankfully, these areas are not super absorptive because that's where most of our exposure is going to occur. So like I said before, a lot of pesticide exposures are dermal, so precisely 97% of all pesticide exposures are going to happen through the skin. The most common route is going to be through the hands and the forearm. And dermatitis, which is basically inflammation or irritation of the skin, is going to be the most commonly reported symptom associated with this type of pesticide exposure. So another type of exposure is eye exposure. So this is going to be when absorption of a product happens through our eyes. This can actually be pretty significant because there are a lot of blood vessels near our eye surface and they can quickly absorb that pesticide. So serious eye exposure can result from splashing during mixing and loading, when a spill occurs, or even drift. So think about, pouring from a jug. Sometimes you get that like glug glug and the splash. So you really want to be careful with that. And then another way that eye exposure can happen is from rubbing our eyes with our contaminated gloves, hands, or clothing. So we want to be really cautious when working with pesticides that we don't do those I can't think of the word I want to use, but those kind of like nervous tics or those unknown activities. I see a lot of people, and I myself, do throughout the day. You touch your forehead, you scratch your ear, you rub your eyes, we do those things and we don't even realize we're doing them. So when we're working with pesticides, we want to be really cautious that we're not doing those things so we don't get pesticides on our face or in our eyes. Inhalation exposure is typically going to occur by breathing mist, vapors, or dust. This is more common when you're working with pesticides in confined or poorly ventilated areas. And unfortunately, lung exposure is the fastest way to get that pesticide into your bloodstream. Think about your lungs and their function. Basically, they exchange oxygen and carbon dioxide with our bloodstream. So anything that you get into your lungs is almost immediately going to be absorbed into your bloodstream. And then oral exposure is going to happen from splashing. Again, that pouring of that product. So this is going to be typically during mixing or cleaning of containers and equipment. If you would be not very smart and decide to siphon with your mouth, you can expose yourself orally to pesticides that way. Not washing your hands before eating, drinking, or smoking, or even using your cell phone. And oral exposure can also happen because of improperly stored pesticides, whether we're storing them in containers we shouldn't be, or we're storing them with food products. So a little bit more on that hazard equals toxicity times exposure equation. So toxicity is going to also play a very important role in determining the hazard or risk of the pesticide product. And there are two types of toxicity, two different ways that we would measure toxicity associated with a pesticide. The first one's going to be acute toxicity. So this is going to be a single one-time exposure to a pesticide. The symptoms are going to occur shortly after the exposure and normally within about 24 hours of that exposure event. And then we have chronic exposure, or chronic toxicity, Chronic toxicity is when we have repeated exposure to small amounts of pesticide over a prolonged period of time. And symptoms of a chronic exposure may not show up for many, many years. Sometimes, it can be 20 years down the road until that exposure, that chronic exposure shows up, that toxicity from those chronic exposure events. So to really understand the toxicity of a pesticide, we want to focus on the signal words. So the signal words are going to be located on the label of the pesticide. They're actually going to be on the front of the label of the pesticide. They're going to correspond to the LD50 range, which is the lethal dose 50 range. And signal words are only related to the acute toxicity of that pesticide and how that acute toxicity reflects with humans and animals. Signal words are going to measure the acute toxicity for skin, mouth, lungs, and eye exposure. Okay, and so we want to reflect back on that equation. So hazard, again, equals toxicity times exposure. Do any of you know the 4 signal words? There is 4 of them. I'll let you think about it for a minute. All right, so the 4 signal words are caution, warning, danger, and danger, poison. Don't forget them. As you can see here on this label, keep out of reach of children and caution. So what are some causes of direct and indirect exposure to pesticides. So direct exposure from pesticides can happen when we're dealing with the pesticide formulation, when we're mixing and loading pesticides, when we're measuring out that concentrated pesticide formulation. We can have direct exposure at the application site. So for example, maybe you sprayed a big area and you dropped something and you have to go back for it. So now you're going to walk back through that area that you already applied pesticide on. You want to make sure you have proper PPE on to do that, because if not, you're going to be exposing yourself to those pesticides. Exposure can happen during maintenance or in your storage facility, while cleaning up a spill, or when you're disposing of pesticides or their containers. We can have a pesticide exposure happen because something happens with your PPE. Maybe you're reusing something that you shouldn't be, or it just has a blowout or a breakout or a rip or a tear. So you want to make sure that your PPE is up to snuff. It's good stuff and it's clean, it's fresh, it's working properly. And just as a reminder, putting duct tape over a tear does not fix your PPE problems. And then, bad hygiene habits. We really want to make sure that we're washing our hands before we eat, drink, smoke, chew tobacco, use our cell phone. Whenever we're dealing with pesticides, you always want to wash your hands. It doesn't hurt to wash them just one more time, just to be safe. And so those are examples of how we have direct exposure from pesticides. Our indirect exposure is going to happen when we're dealing with pesticide residues. So if you wear reusable PPE and you don't clean it properly, the next time you go to use it, you're going to be exposing yourself to those pesticide residues. We can also come in contact with residues when we're mixing and loading pesticides, whether it's still in the equipment, the measuring devices, things like that. Anytime you're doing maintenance on equipment, you can be exposed to those pesticide residues. So you want to make sure that you're wearing the proper PPE while doing that maintenance. Again, if we're storing pesticides improperly or we're storing them mixed with foods and drinks, again, you can consume pesticide residues with your food and drinks. And lastly, we want to always make sure we're wearing PPE when we're laundering our work clothes that we have used to apply pesticides, because there is always going to be residues on those, on those pieces of clothing. So now we're going to talk a little bit about different pesticide formulations that we maybe need to be a little bit more cautious about when we're dealing with them, so we can prevent these direct exposures. So the first one I want to talk about is emulsifiable concentrate. So emulsifiable concentrates are products that have their active ingredients dissolved in a petroleum-based solvent with an emulsifier added. These products are petroleum-based or oil-based, which means they are very easily absorbed by our skin. Think about lotions or moisturizers that you put on your skin. Those things are oil-based or petroleum-based for that matter. And their purpose is to absorb into the skin, right? That's why you put them on. Well, the same thing happens with our emulsifiable concentrates. They will readily absorb into our skin. So we want to make sure that we are protecting our hands and our forearms when we're working with these products. So again, how can you protect yourself? Wear your PPE, especially that long sleeve shirt and gloves. Even if the label does not call for gloves, still wear the gloves. It's just an extra level of protection that's going to help you in the long run. The next formulation I want to talk about is a wettable powder, or WP. So WPs, or wettable powders, as I said before, are dry pesticide formulations that are finely ground. So the formulation is a solid material and it's going to be finely ground into a really fine powder. Think about flour, for example. Okay, the concentration of, what flour is like, right? So flour is an example of a wettable powder. So these pesticides are that formulation, and they can pose a lot of hazard to our eyes or to our mouth, our respiratory system, because when you open that bag, you get that poof. They're very fine, they're very dusty and dry. So we want to be cautious that we're not, opening the container with our face over it, or we're not really working with that or trying to measure it or mix it in an area that's going to be really windy, because there's a chance that we're going to get some of that dust blown into our eyes or into our respiratory system. So you can protect yourself by wearing a face shield. You know, this is good just when you're mixing and loading. You don't have to wear it the whole time you're doing application, and or of course eye goggles. Another pesticide formulation that we see sometimes we get increased exposures is these water-soluble packets. Basically, they're like Tide Pods or dishwasher pods. I think you guys know what I'm talking about. And this was a newer technology that was invented to help reduce pesticide exposure, because the pesticide is inside of this little packet that's supposed to dissolve in water or in your tank mix. So an applicator should not have to have any direct handling of the pesticide by wearing gloves, because it's already like a pre-measured little pack. But there was some issues with this. So there are specific instructions on the label that applicators needed to follow when working with water-soluble packets, and they weren't doing it. So instead of, putting the water-soluble packet directly into the tank, they were putting it in the basket and then spraying water on it in the basket, and then the pesticide was splashing back on them. Some people were tearing open the water-soluble packets, or they were adding it at the wrong time, so after fertilizers or other pesticides, and then it wasn't dissolving properly. And, unfortunately, some of these water-soluble packets do get damaged, and so using a damaged one was not recommended, because that can increase your pesticide exposure. So how can you prevent pesticide exposure when using a water-soluble packet? First, you want to let the water and the agitation in the tank dissolve the water-soluble packet. You do not want to break that open on your own. And you want to always add the other products or fertilizers after that water-soluble packet has been fully dissolved. So how can you protect yourself? Wear gloves. I know, I'm like a broken record. I say the same thing all the time. Wear gloves and follow those mixing instructions on the label. So you can be directly exposed to pesticides when mixing and loading. So when you're trying to open a pesticide container, we don't want to be using our thumb to open the foil on the container. We want to use something that's designated only for opening pesticide containers. We can also, be exposed when we are pouring pesticides into the spray tank, whether we're pouring a liquid and it kind of splashes back on us, or if we are working with a dry formulation and we're getting dust, or we're breathing in some of the other, particles that are associated with that pesticide. And again, splashing from liquids, whether that liquid's going to splash when we're measuring it or when we're pouring it into the tank. We can get that actual concentrate splashing back on us, or even the diluted version, but we still don't want that to happen. So how can you prevent those things from happening? Be aware of the weather. Make sure you're standing upwind when you're mixing these products. Take a deep breath. If you're having a rough day, take a deep breath, take a minute to kind of relax yourself so that you're more cautious to avoid spills. Spills do happen. Accidents happen. That's why they're called accidents. But, if you're having a really rough day, you want to make sure you just take a moment, kind of like relax, let your blood pressure settle down a minute before you continue to work with these pesticide products. And how can you protect yourself? Wear the PPE, so gloves and an apron and a face shield are always recommended when you are mixing and loading, because you are working with that concentrated version of that pesticide product. And, another way that we can have this direct exposure is when we're measuring out pesticide products. So first and foremost, you want to make sure you have dedicated measuring devices, only for use with pesticides. And if the manufacturer provides a measuring device, use their measuring device. This is very important, especially with dry formulations, because those dry formulations have different sizes and shapes of their particles, and they weigh different things. You need to use the measuring device that is provided for that dry product, because any old measuring device is not going to be very accurate. So you want to make sure that you're going to measure the proper amount. So again, liquid formulation measuring devices are different than dry. You cannot intermix them. And thankfully, liquid measuring devices are going to be consistent regardless of the product. So you can have just one device dedicated for liquids, but it's also important, if you're using a product that you only need, a half an ounce or an ounce or, an ounce and a half, like you're going to want something that's got a lot of graduations on it so that you can really precisely measure that product out. Because if you're trying to measure out an ounce and a half in a gallon container, that's going to be really hard. So you want to have different sizes of liquid measuring devices so that you can accurately measure what you need. And then again, back to that dry product, you want to make sure that you're using the measuring device that is provided with that dry product. So how can you prevent exposure when you are measuring your pesticide products? Again, only use dedicated measuring cups and utensils that are specific for pesticide use only, and make sure you're using correct sizes and utensils. And again, how can you protect yourself? Wear gloves to protect your hands. I know you're tired of hearing that, but that's the biggest takeaway from this whole presentation probably today, is to make sure you wear gloves to protect your hands. So when you're working with pesticides, you can be directly exposed to them at your application site. One of the ways this can happen is when if you would breathe the spray or the spray mist in. And so how can you prevent yourself from breathing in that spray or the spray mist? You want to make sure you check your wind direction before you do that application. You want to start your application when possible. I know it's not always possible, but when possible, you want to start that application downwind side of the property so that you are not walking, as you're doing your application, the drift, the mist, the spray is not following you. So you want to work downwind. So how can you protect yourself? Wear the appropriate PPE for the product that you're using. And again, you'll find that on the label. If you're going to walk through an area that was recently sprayed, make sure you're wearing that proper PPE, because if you're not wearing proper PPE, you can be directly exposed to that pesticide. And when you're doing your application, again, make sure that you are wearing the PPE that is required by the label. And at a minimum, it's going to be long sleeve shirt, long pants, shoes, plus socks. And I always like to add in gloves, even if the label doesn't call for it. Just putting on those gloves is just going to save you so much over the years of pesticide exposure. So if you've done an application recently, you want to make sure you're going to post signs to indicate that the area was recently treated. This is going to be especially important on areas where there's a lot of people. So like orchards, there's a lot of people coming and going through that area, even landscape, turf, golf course, that kind of thing. It's good to put signs that that area was recently sprayed and to stay out of it. And again, how can you protect yourself? If you have to go back through that application site within that restricted entry interval, make sure that you are wearing the proper PPE. So pesticide exposure can occur during maintenance. This can happen when we're inspecting, maintaining, repairing, or cleaning our application equipment. This normally is going to occur when we're unclogging or changing our nozzles. Sometimes it'll happen if we're checking or repairing hoses and if we're checking strainers, because these are the areas where really that pesticide product is found most often on the application equipment that we're using. So how can you prevent direct exposure during maintenance? Regularly check and replace your nozzles, hoses, strainers, etc. Keeping those things in good shape and working well is going to save you a lot, especially out in the field, because nobody wants to be in the middle of spraying and have a big blowout. And again, how can you protect yourself? Always wear the proper PPE, even when you're doing maintenance work, just in case something leaks or, a spray event happens out of control. And I know none of you do this, but never use your mouth to unclog a nozzle. You want to use a dedicated toothbrush or have a can of compressed air, on your application equipment to take care of that clogged nozzle. Never blow on it. So we can have direct exposure when we're improperly storing our pesticides. So do not ever put pesticides in food or drink containers. Do not put them in a container without a label. Always make sure they are labeled. Do not store containers with spilled pesticides down the side. I think a lot about the one liquid formulation that is the chemicals atrazine. It's like real chalky, whitish product. And whenever you're measuring it, it's real thick and it always ends up like catching on the edge of the bottle and then it runs down it. So take the extra moment to wipe that container off before you put it back so that that product does not dry on the side of the container. And then you don't have to worry about being exposed to it every time you come in contact with that container. And not cleaning up any spills or leaks that occur. So how can we prevent exposure from improperly storing of pesticides? Always keep the pesticides in their original container unless it's cracked or there's something wrong with it. Then you can put it into a service container, but try to always keep them in their original containers. You want to attach a copy of the label to the container if the original is damaged or unreadable. Clean the outside of containers after pouring and immediately clean up any spills or leaks that occur. So pesticide exposure can happen during a spill. Spills are accidents. Sometimes spills are preventable, but a lot of times they're not. So you can be exposed to pesticides when you're trying to contain, control, or clean up that spill. So you want to make sure your equipment is well maintained and you want to be aware of your surroundings, kind of know what's going on. And having that equipment, up to snuff is going to be really helpful for preventing spills from happening. And again, when you are dealing with a pesticide spill, wear the appropriate PPE anytime you handle a pesticide. We know accidents happen and a lot of times they happen at unexpected times, but make sure you have the proper PPE on. This will really help you prevent direct exposure from pesticides. So when we are rinsing or cleaning out our containers, doing that disposal process, sometimes if we haven't completely cleaned that pesticide container on the outside, we can be exposed to pesticides, and we can also be exposed to them during the actual rinsing out process. So we want to make sure that we clean the outsides of the containers when we're mixing or pouring pesticides. And again, make sure that you are wearing the approved PPE to protect your eyes, hands, and body from that splashing rinsing. Whether you're pressure rinsing or triple rinsing, you definitely want to make sure you're wearing PPE. And after that container is rinsed, you want to puncture it and so that it cannot be used for anything else. Direct exposure can happen when your PPE fails you. And so failing to clean your PPE, so reusable products like gloves and goggles, can result in direct exposure. Disposable PPE is supposed to be disposed of after one-time use. It's not to be reused. It's not going to be waterproof. It cannot be washed, and it typically is not good for more than 8 hours of use. So we want to make sure that we are disposing of our disposable PPE. So I know it kind of looked like he had a strap hanging down his back. It's actually duct tape on his Tyvek suit that got a rip in it. That is not proper. Do not duct tape your Tyvek suits. Just put a new one on. So how can you prevent exposure? Again, inspect that PPE before you use it. If it's reusable, make sure you clean and inspect it after each use. Know your limitations. PPE is designed to protect us, but certain products work better in certain environments. So know, what kind of environment you're getting into and the best PPE that you should use. And any PPE that has a hole or a crack or just looks different or off, throw it out, start new. It's worth it. It'll help you in the long run. Direct exposure can also happen from bad hygiene habits. So improperly removing your PPE, not washing your hands before eating, drinking, smoking, going to the bathroom, or using your cell phone, not washing your work clothes regularly, and washing your work clothes with family laundry. All of these things can result in direct exposure to pesticides. How can you protect yourself? Make sure you know the process for properly removing your PPE. Always wash your hands after using pesticides, and wash your work clothes regularly, but keep them separate from your family laundry. So the common theme here, I think you've already figured it out. Wear your PPE, right? Wear at least the minimum PPE is required by the pesticide label. And feel free to wear more. You don't have to wear the minimum. That's not what I wanted to say. You have to wear the minimum, but that doesn't mean you can't wear more than that. That's what I mean. Make sure your PPE is in good condition. And think, pay attention to what you're doing. Make sure you're focusing on the task at hand, the pesticide application process when you're mixing, loading, and applying. Wear that minimum PPE specified on the label, and wear the gloves. If it doesn't call for gloves, still wear the gloves. It's going to help you in the long run. It's just a better way to protect yourself. So our personal protective equipment is going to be found on our label under personal protective equipment, PPE. Again, that standard work clothes is always going to be long sleeve shirt, long pants, shoes plus socks. Feel free, go for it, add on some protective eyewear, put on those chemical resistant gloves. It's going to help you out. And that's it. Thank you, everyone. I hope you have a wonderful day.
Okay, thank you, Jenny. We have
Very
time
good,
for questions.
It's awesome. I never realized about the pods or the Tide Pod things as far as getting those in the tank versus just putting them on the screens and stuff like that. I really never thought about that. So it's interesting.
Yeah, mixing order is really important with those, and you want to make sure that they're completely dissolved before you're adding other things into that tank.
It's interesting. It's always good. I learned something from those every time, so that's good. Thank you, Jenny.
I didn't see any questions, John.
One just came in about any recommendations on respirators.
So reality is respirators, you have to follow exactly what the label is going to say. It's going to call for the specific type of respirator plus the cartridges. And if you are using products that require respirators, you need to have a respirator fit test. And so I'm going to call out Brad. Brad couldn't wear a respirator because he has facial hair. Or John could wear a respirator, but you need to have a fit test, which means you need to, I don't know. My directions and your directions are different. So you need to have a fit test, which means you need to basically have doctor approval, and then you need to have your respirator professionally fit to make sure that it is working properly. And, cartridges are set up for 8 hours, start to finish. Typically, again, you're going to want to read the labels because there's so much variety. We can't just generalize information about respirators.
Okay. Are you sticking around till the end?
Yes.
Okay, so if anybody does have a question, obviously put it into the Q&A and we'll address that, but we'll get started on the next talk here. All right, our final talk of the week, talk number 15, is going to be from Dr. Landscoot. Dr. Landscoot's a professor of turfgrass science in the Department of Plant Sciences at Penn State. His primary responsibilities include turf extension, research, and teaching case studies courses. His current research includes turfgrass weed management and naturalized grass stands, soil fertility and fertilizer use, as well as warm and cool season species and variety evaluations. So let me get this started.
Grass weeds are without a doubt the #1 summer turf weed problem in Pennsylvania. Whereas pre-emergence herbicides keep annual grass weed populations suppressed in most years, during hot, rainy summers, breakthrough of crabgrass and goosegrass can result in unsightly turf and complaints from users. Perennial grasses such as nimblewill, creeping bentgrass, Bermuda grass, and Poa trivialis represent a tougher situation as selective control is either non-existent or requires multiple herbicide applications. In this presentation, I'll be covering post-emergence control of the major summer annual grass weeds in Pennsylvania, including crabgrass, goosegrass, foxtail species, barnyard grass, as well as a relative newcomer to some parts of Pennsylvania, Japanese stiltgrass. Then we'll briefly discuss control of a few of the most problematic perennial grass weeds of lawns in Pennsylvania. I decided to include Japanese stiltgrass in this presentation because it is an emerging weed problem in some areas of Pennsylvania and can be easily confused with other weeds, leading to misplaced herbicide applications. Japanese stiltgrass, also known as Nepalese browntop and Mary's grass, is a highly invasive summer annual grass weed often found along roads bordering wooded areas, in infrequently mowed naturalized rough areas on golf courses, as well as in shaded or partially shaded parks and lawns. Introduced from Asia in the early 1900s as packing material for porcelain containers, this warm season grass species has spread throughout much of the eastern part of the United States. Japanese stiltgrass thrives in moist soils and in sites with heavy to moderate shade. It can also persist in full sun, usually in disturbed areas with poor soils or rocky outcrops. This species is widely distributed in Pennsylvania and is becoming a lawn problem, mostly in the southeastern portion of the Commonwealth, although I have identified it in lawns in and around State College. Seed of Japanese stiltgrass begins to germinate in late winter or early spring, a few weeks before crabgrass seed starts to germinate. Following germination and emergence, plants make rapid vegetative growth during late spring and summer and spread over turf grasses by horizontal runners or stolons. Seed heads are produced from late summer to October and generate between 100 and 1,000 seeds per plant. Seed of Japanese stiltgrass is easily disseminated via mowing equipment, shoes, clothing, animal fur, and even flooding. Plants turn brown and die after several frosts in fall, and seeds that have dropped to the ground give rise to new plants the following spring. Seeds can remain viable in soil for several years. Foliage of Japanese stiltgrass can be easily confused with nimblewill, crabgrass, and a broadleaf weed species called Pennsylvania smartweed. Leaves of stiltgrass are usually pale green, lance-shaped, about 1/2 inch wide and 2 to 4 inches in length, often with a silver stripe running lengthwise down the center of the leaf. Leaves are arranged alternately on upright stems and are spaced relatively far apart on each stem. Stems are long, thin, and branching. Initially upright, stems tend to lay over and form a dense mat when not mowed. Another characteristic feature of Japanese stiltgrass is shallow rooting and aerial rootlets or stilts that initiate from nodes on stem bases and extend into the soil, hence the name stiltgrass. Inconspicuous seed heads are arranged on slender stalks and contain 1 to 3 seed-bearing spikes. Seeds are small, typically about 3 millimeters in length, elliptical in shape, and sometimes have twisted awns at tips, as shown in this slide. Just about everyone with significant turf management experience knows that the most effective means of controlling summer annual grasses is through cultural measures that create a dense turf, such as fertilization and using proper mowing heights, as well as the use of pre-emergence herbicides in spring. However, when cultural practices and pre-emergence herbicide control measures fail, post-emergence herbicides can be used. Post-emergence control of crabgrass and other summer annual grass weeds involves the use of herbicides that kill growing plants after they have appeared in the turf. Post-emergence herbicides can be used to treat only those areas where summer annual grass weeds have emerged. Pre-emergence herbicides, on the other hand, are usually applied over the entire turf area since the applicator does not know where the seeds are or even if they are present. For post-emergence herbicides to be effective, grass weed leaves must be covered uniformly with spray droplets. Thus, these chemicals should be applied only when foliage of annual grass weeds is at or above the turfgrass canopy and visible in the stand. Environmental conditions also play an important role in post-emergence control of annual grasses, with adequate soil moisture and moderate temperatures generally providing the best results. Only apply post-emergence herbicides when rain is not expected that day, and for best results, do not mow the turf for about 48 hours before and after the application to make sure the herbicide contacts leaf tissues and is taken up and translocated to the growing points of the target plant. The effectiveness of the herbicide that you choose in controlling annual grass weeds will depend on the target species, the stage of growth of the weed, which I will discuss in the next few slides, and the corresponding herbicide rate. Thus, applicators must pay close attention to herbicide product label directions regarding rate and growth stage of weeds. The stage of growth of summer annual grasses will dictate which herbicide and rate is best used for complete control. Growth stage is determined by counting the number of leaves on seedling plants and the number of tillers on mature plants. In this photograph, crabgrass plants are just emerging from soil and most have only 2 leaves per plant. These plants would be killed with a single application of any of the post-emergence herbicides labeled for crabgrass. A potential problem with plants this small, however, is that if these plants were in a lawn mowed at a 2-inch height, the herbicide spray droplets might be intercepted by the turf foliage and could miss some of the tiny crabgrass plants. Plus, at this early stage of growth, there will probably be more plants emerging over the next few weeks, so a herbicide with pre-emergence activity would also be needed. In this slide, the crabgrass plant on the left is still in the seedling stage, but now has 3 visible leaves and is probably tall enough to be visible in the turf canopy and intercept herbicide spray droplets. Some weed scientists would consider this plant to be at the 2-leaf stage because, technically speaking, the first leaf produced by a grass plant is called a coleoptile instead of a leaf. However, for practical purposes, we can consider this plant to have 3 leaves. The plant on the right side of the slide has 4 leaves and no tillers. A tiller is a shoot or stem other than the main stem of a grass plant. Typically, when grass plants reach the 5-leaf stage, they begin to produce tillers. This slide shows a crabgrass plant with 2 tillers, or 2 stems other than the main stem. Once annual weed grasses begin to tiller, counting leaves is of little relevance, and the number of tillers becomes the determining factor for selecting an effective herbicide and application rate. This slide shows crabgrass plants representing several different stages of growth, ranging from seedling plants on the left to a plant with at least 3 tillers, perhaps 4 on the right. It's a bit hard to determine, but it looks like a 4th stem may be starting to develop from the crown. By the way, all of these plants were collected from the same lawn on a single day in early July, thus illustrating one of the problems in trying to assess the proper herbicide rate based on growth stage. Sometimes the best you can do is examine a few annual grass plants in several locations in a lawn and select an appropriate herbicide and rate for the most mature plants in the stand. This table shows the names of active ingredients and some corresponding product names of 5 post-emergence herbicides that control summer annual grass weeds in cool season turf grasses. I'll go over each of these herbicides in the next few slides. Dimension, along with some other post-patent products, contains the active ingredient dithiopyr and is best known as a pre-emergence herbicide. It is available in several formulations, including a 2-EW, which is an oil and water emulsion, EC or Emulsifiable Concentrate, a Wettable Powder formulation, as well as a granular formulation. It is labeled for use on all cool season turf grasses, with some restrictions on certain bent grasses and fine fescues. It is not labeled for use on putting greens. Use rates range from 0.25 to 0.5 pounds active ingredient per acre, and sequential applications can be made at 5 to 10 week intervals. Dimension is labeled for pre-emergence control of crabgrass, goosegrass, foxtails, barnyard grass, and other summer annual grasses, including Japanese stiltgrass. In fact, it is the only pre-emergence herbicide labeled for control of Japanese stiltgrass. I should note that this species is listed on the dithiopyr product labels as Mary's grass, an alternate common name for Japanese stiltgrass. It also offers pre-emergence control of a number of annual broadleaf weeds. Dimension provides post-emergence control of crabgrass only, and only up to the 4-leaf stage and prior to tiller initiation. It does not control goosegrass post-emergence. If using this herbicide primarily for post-emergence control, do not irrigate for at least 6 hours to ensure foliar absorption. Keep in mind that there is a 3 to 4 month seeding interval following application of Dimension, regardless of whether it is applied pre or post-emergence. This would be a good herbicide to use in a 2-application program where the second application is made after some early crabgrass emergence has taken place. So, just as an example, Dimension would likely provide post-emergence control of these 3 and 4-leaf stage crabgrass plants, but not older plants beyond this stage. Tenacity and some other post-patent products contain the active ingredient mesotrione. This systemic herbicide provides pre- and post-emergence control of certain grass and broadleaf weeds. It is available in liquid soluble concentrate and granular formulations, and is labeled for use on most cool season turf grasses, with some rate restrictions on perennial ryegrass and fine fescues. It is not labeled for use on bentgrass. Use rates for cool season grasses range from 5 to 8 fluid ounces per acre. Post-emergence applications require addition of a non-ionic surfactant, and a second treatment after 2 to 3 weeks is usually needed for complete control of summer annual weeds. Total seasonal applications of Tenacity should not exceed 16 fluid ounces per acre. Tenacity is labeled for pre-emergence control of crabgrass, yellow foxtail, barnyard grass, but not goosegrass. Tenacity provides post-emergence control of crabgrass, foxtail, barnyard grass, and goosegrass when applied to plants with fewer than 4 tillers. This herbicide can also provide post-emergence control of creeping bentgrass, nimblewill, and nutsedge, as well as several species of broadleaf weeds. Tenacity works by inhibiting synthesis of yellow and orange carotenoid pigments in susceptible plants, which protect chlorophyll from the damaging effects of ultraviolet radiation. The result is no yellow or green color in foliage, and susceptible plants turn white before they die. Translocation of the active ingredient must result in greater than 50% whitening in order to achieve effective control. And this does not often occur in annual grass weeds beyond the 3-tiller stage. Use of Tenacity and similar herbicides like Pilex, which I will discuss next, creates a highly visible treatment effect for 2 to 3 weeks following application. Thus, homeowners and other turf users should be aware that weeds will have a white cast while the treatment takes effect. Perennial ryegrass is somewhat susceptible to the effects of Tenacity, so some temporary injury may be observed on this species. The Tenacity label suggests limiting rates to 5 fluid ounces per acre when applied to perennial ryegrass. Pilex herbicide contains the active ingredient topramazone. The mode of action, carotenoid pigment inhibition, and systemic activity are similar to mesotrione or Tenacity. However, it possesses some important differences in the weed species controlled or suppressed. Pilex is available as a liquid formulation and is labeled for use on most cool season turfgrass species. However, bentgrass is listed as only moderately tolerant. Rates of Pilex range from 1 to 1.5 fluid ounces per acre per application for control of annual grasses in most turfgrass stands, but applications up to 2 fluid ounces per acre can be made on pure stands of Kentucky bluegrass. The total seasonal amount of Pilex is restricted to 4 fluid ounces per acre. It is most effective in controlling summer annual grasses when mixed with a methylated seed oil or crop oil concentrate type of surfactant. Pilex can be mixed with pendimethalin or pendulum and quinclorac or Drive XLR8 for improved control and spectrum of activity. Like tenacity, Pilex, when used alone, is labeled for selective pre-emergence control of annual grasses in new establishments, and post-emergence control of crabgrass, goosegrass, barnyard grass, foxtails, and Japanese stiltgrass in recently established or established turf. It can be applied anytime before seeding tolerant cool season turf grasses or 28 days after seeding. Best post-emergence control of summer annual grasses is obtained when Pilex is applied to plants with fewer than 4 tillers. Pilex can also control numerous broadleaf weed species, as well as control or suppress some perennial grass weeds in turf, including nimblewill, Bermuda grass, and Dallas grass. Unlike tenacity, Pilex is not labeled for control of creeping bentgrass. Pilex has been shown to be a particularly good herbicide for controlling goosegrass post-emergence, at least up to the 4-tiller growth stage and perhaps older, more developed plants. Like tenacity, susceptible weeds turn white before they die, creating a highly visible treatment effect. The whitening effect can be reduced somewhat when triclopyr ester is mixed with Pilex. The addition of triclopyr also aids in suppression or control of Bermuda grass. Acclaim Extra, active ingredient phenoxyprop P-ethyl, is a post-emergence herbicide formulated as a water emulsion that is slowly translocated within the plant and can control tillered summer annual grasses with a single application. It is relatively safe on most cool season turf grasses, but can injure some Kentucky bluegrass and bentgrass cultivars when high rates are used, especially during periods of high temperatures. Rates of Acclaim Extra range from 3.5 to 39 fluid ounces per acre, with suggested use rates increasing as the number of tillers on annual grasses increase up to 5. On Kentucky bluegrass, the rate should be limited to 28 fluid ounces per acre per application. A surfactant is not required with this herbicide. Acclaim Extra has no pre-emergence activity, but it can be mixed with most pre-emergence herbicides, including pendimethalin, prodiamine, and dithiopyr, as well as some post-emergence broadleaf herbicides such as quinclorac and dicamba. However, its efficacy is reduced when mixed with herbicides containing 2,4-D and MCPP. Acclaim Extra controls crabgrass, goosegrass, barnyard grass, foxtail species, as well as Japanese stiltgrass. Applications are most effective when applied prior to the 5-tiller growth stage. This herbicide should not be applied if cool season turf is showing signs of drought stress. Acclaim Extra belongs to a group of herbicides called the ACCase inhibitors, which are slow-acting but very efficient in translocating the active compound to growing points and eventually killing plants. Affected weeds take on yellow and reddish colors and fade from the stand within a couple of weeks. As previously mentioned, Acclaim Extra can injure Kentucky bluegrass when applied at high rates during midsummer. This slide shows a plot of Kentucky bluegrass with a reddish purple tint 20 days after treatment with 28 fluid ounces per acre of Acclaim Extra during a hot period in midsummer. The turf eventually recovered when cooler temperatures returned. Drive XLR8 and several other post-patent products contain the active ingredient quinclorac, which is a systemic herbicide that belongs to the same group as synthetic auxin herbicides such as 2,4-D, MCPP, and dicamba. Hence, it has excellent post-emergence activity on many broadleaf weeds. This herbicide is unique in that it also has pre-emergence and post-activity on some summer annual grasses. Drive XLR8 is safe to use on most cool season grasses, but the label suggests applications on fine fescues only when mixed with other lawn grasses. Lower rates and split applications are suggested for use on creeping bentgrass. The label rate of Drive XLR8 is 64 fluid ounces per acre on established turf and a methylated seed oil should be added for optimum post-emergence performance. The rate limit for one season is 128 fluid ounces per acre. Drive XLR8 can also be mixed with pendimethalin products for pre-emergence control of late germinating annual grass seed. Drive can also be used as a pre-emergence and post-emergence herbicide for new turfgrass seedings. However, if you plan to use this herbicide for new establishments, be sure to read the label carefully as it gives different application intervals before seeding and following emergence of specific turfgrass species. For example, tall fescue seedlings can be treated 7 days after emergence, whereas Kentucky bluegrass should not be treated until 28 days after emergence. Drive XLR8 is widely used as a post-emergence herbicide for control of crabgrass, foxtails, barnyard grass, along with broadleaf weeds. However, it does not control goosegrass and Japanese stiltgrass. This herbicide controls newly emerged summer annual grasses as well as mature annual grasses with more than 4 tillers. However, for some reason, it may not provide consistent control of annual grasses with 2, 3, or 4 tillers. Thus, it is a good product to use for crabgrass control early in the season and later in the summer. This slide shows the type of young, 1 tiller or less, and older, 5 or more tiller crabgrass plants that Drive XLR8 and other quinclorac products are most effective in controlling. This is a photograph of a crabgrass-infested golf course rough in mid-July, where Drive XLR8 was used to control crabgrass plants that exceeded 4 tillers. In summation, all post-emergence summer annual grass herbicides will adequately control emerged crabgrass up to the 2-tiller growth stage, with the exception of Dimension and other dithiopyr-containing products, which only work up to the 4-leaf stage. Acclaim Extra would be the post-emergence product of choice when significant numbers of plants are between the 3 and 4 tiller stages, whereas Drive XLR8 is the best product to use for late season post-control where 5 or more tillers are present on crabgrass plants. For goosegrass, Acclaim and Pilex are the most effective products up to the 4-tiller stage. After that, Pilex would be the product of choice. Keep in mind that some crabgrass and goosegrass seeds can still germinate after early season post-applications are made, so applicators should consider combining a pre-emergence herbicide with post-emergence herbicides during the summer annual grass germination period. Perennial grasses are much more difficult to control selectively in cool season turf stands than annual grasses. Creeping bentgrass can be controlled selectively with multiple applications of tenacity, and nimblewill can be controlled or suppressed with tenacity or Pilex. As mentioned earlier, Pilex is also labeled for control of common Bermuda grass, zoysia grass, and Dallas grass. Unfortunately, other common perennial weed grasses such as Poa trivialis, quackgrass, and orchard grass cannot be removed with selective post-emergence herbicides and can only be killed with non-selective glyphosate-containing products. Although bentgrass is the preferred species for golf course fairways, tees, and greens, it is one of the most serious weed problems in lawns in Pennsylvania. Although tenacity is labeled for control of creeping bentgrass, it will likely take 3 applications at the 5 fluid ounce per acre rate at 2 to 3 week intervals in midsummer to late summer to kill plants. My experience with tenacity is that some cultivars or ecotypes of creeping bentgrass are more difficult to control than others, so results of eradication programs may vary from one site to another. Nimblewill is a common lawn weed in Pennsylvania and notoriously difficult to control with selective herbicides. Like bentgrass, nimblewill control will likely require 3 applications of tenacity at the 5 fluid ounce per acre rate at 2 to 3 week intervals. Despite receiving multiple applications, some nimblewill plants may recover and appear in the turf the following year. Hence, control programs may involve a long-term approach. The Pilex label also makes recommendations for selective control or suppression of nimblewill, and for 3 other perennial grass species, common Bermuda grass, Dallas grass, and zoysia grass. The procedure outlined on the label involves 3 applications of Pylex at 1 to 1.33 fluid ounces per acre, along with a methylated seed oil or crop oil concentrate surfactant, applied at 3 to 4 week intervals beginning in mid to late summer. The addition of triclopyr ester aids in suppression or control of Bermuda grass. As with summer annual grass weeds, it's important to have good uptake and translocation of mesotrione, the active ingredient of tenacity, and topramazone, Pylex, for adequate control of perennial grasses. If the application was successful, target plants should show greater than 50% foliar whitening several days after application. In summary, conditions needed for successful control of perennial grass weeds with post-emergence herbicide applications include adequate soil moisture, moderate temperatures, and lack of rain at the time of application. To maximize foliar contact and uptake of herbicides, it's best not to mow for about 48 hours before and after application. Multiple applications during late summer are generally most effective because they allow less time for recovery of target weeds before winter. Finally, be sure to follow label directions for any additives that may improve herbicide efficacy.
All right, can everybody hear me?
Yep. Awesome.
I had my headphones out in the very last seconds of that, and then I didn't see it end. It was quick. All right, so we have time for questions for any of the speakers, Brad, Jenny, or Pete, if anybody has anything.
There is one for Pete. We'll kind of, we got a couple actually here. A couple here for you, Pete. How does UV exposure affect the effectiveness of dimension if the timing of a granular application cannot be controlled and cannot be immediately watered in when natural irrigation is the only source of water?
Yeah, it's a little vague. Yeah, like all, like most pre-emergence herbicides, especially dinitroaniline herbicides, UV radiation can degrade those products. Usually what the label says is water these in within about 2 to 3 days in order to become effective. It's a good question regarding post-emergence applications though, because you don't want to water those in. Presumably those are going to be taken up almost immediately. Once they're in the plant, I don't think that really makes a difference. And UV light doesn't make a difference anymore. But again, for pre-emergence herbicides, get those watered in within a couple of days. You know, the more light you have too, you know, the more intense the sunlight, the more it's gonna rapidly break down those products.
Okay. Next question: does snapshot control stilt grass in beds?
What's the active ingredient in snapshot?
Oh,
I don't really deal with beds very much.
right.
That's not labeled for turf, I don't think.
No, it's not. I don't think. Well, it could be. It's Treflan and Gallery
Oh, wow.
mixed together.
Yeah, you don't want to put Treflan on turf. I don't know.
That I don't know.
Gallery is typically for broadleaf weed, you know, pre-emergence broadleaf weeds. I haven't looked at that label to see if Japanese stilt grass is on there though.
I will tell you, I think Treflan has stilt grass on it. But I guess if you're only going after stilt grass, I would just use granular Treflan as opposed to the combination, because the Gallery is expensive and isn't going to help you with the stilt grass. So unless you're going after everything, then I guess you could use Snapshot.
Do you have that on your property, McNitt?
Yes, a bunch of it.
Okay.
I wondered where it was coming from.
I was wondering why you knew so much about that. I figured you had some.
I walked down through the woods and it's all over, like all the fields around here.
Incidentally, I had several calls on Japanese stilt grass in lawns and in parks this year. Like I said before, I found it in State College. I think it's just spreading around as people walk through the woods, you know, bring their dogs through the woods, they pick up the seed, bring it back to their yards. And if you have a lot of shade, moist conditions, it's going to really take off. And it's the key to getting pre-emergence control of that is to get your pre-emergence herbicides down 2 to 3 weeks earlier than you would ordinarily put them down for crabgrass control. And then if you can't get it pre-emergence, you have to go after it post-emergence with something like a claim or Pilex on turf.
I looked up on the label too, and I don't see Japanese stiltgrass listed on there.
Okay.
On turf, on
the snapshot.
Snapshot.
Yeah, I think if you look up just Treflan by itself, you'll find.
Yeah, and you know, some of these products, they probably do control or suppress Japanese stiltgrass. They just aren't labeled for it yet.
Well, to be honest with you, I never looked at the Treflan label. I was looking at university websites on control, and some of them had Treflan as a half decent control.
I don't think there's been a lot of research done on that in beds and lawns either. Most of the work that's been done on that has been in these wooded areas like state parks, so forth, where it really just overruns everything.
Gotcha.
I always tell everybody just to treat it like crabgrass. Think about it as crabgrass. So if you have a pre-emergent program, you have a post-emergent program, or a combination of both. And obviously read the labels of the products you're using. Like Pete, I'm not very familiar with Snapshot. I haven't used it before, but
well, if you Joe Neal down in North Carolina is one of the few people who's actually done work with this on turf, and his publications say that you got to get your pre-emerged materials down a little bit earlier. So I think it'd be good to do a study up here just to see when those seeds germinate, so that if you do have a problem with that, you can time your pre-emerge applications a little bit better. I don't want to really spread that seed around our turf farm though. Not until I'm about a year away from retirement.
We've got a couple more questions. Let's see here. If you combine triclopyr and Pilex to reduce whitening, should you still add MSO?
Yes, I believe so. I'd have to go back and look at the label to be sure. So don't hold me to this. I can tell you one little funny story about a graduate student. I had to go out and put some treatments down regarding that combination. And I think the triclopyr, I can't remember the product that we used, but it was 32 ounces per acre. And then the Pilex rate was 1 to 2 ounces per acre. And the graduate student got those rates mixed up and put 32 ounces of a Pilex down and 1 ounce of triclopyr. And, I was really surprised that the grass actually survived, but it was white for about 3 months. I think 50% of it died. So that's my experience with that combination. I got to do some more work with that. And the ester formulation is more effective than the amine formulation too.
Okay. So then be I guess, careful of temperatures then, as far as when you're applying that, if it's on the ester base?
Well, always, yes, but when you're going out with post-emergence for summer annual grasses, you're always going to be in warm weather. So, I think it's really important for the first couple of days that you try to look ahead for the weather and not put it down when it's going to be 90 degrees or so.
Makes sense. We got another question here. Recommendation for a pre-emerge for goosegrass.
Prodiamine, pendimethalin. Oh, wait, Ronstar would be the best, okay? Ronstar is the best pre-emerge for goosegrass. If you're going just after goosegrass, I think. Yeah, that's the best. Pete Dernoden did a lot of work with that down in Maryland, and he's written articles on that before and done some pretty good work on that. And then Pilex for post-emergence. And Matt Elmore at Rutgers is doing quite a bit of work on goosegrass control post-emergence. Also, Speed Zone is interesting. Speed Zone, which is a broadleaf herbicide, can control goosegrass post-emergence too, but you have to go with pretty high rates with that.
We've been trying for like 3 years to get goosegrass populations at Valentine.
I know you brought it into our farm this year.
Yeah, but we can't even get it to like develop. I think we have it in the zoysia plots we established, but I mean, we got seed from Matt Elmore at Rutgers and planted fields out of LMRC and just can't get it to populate. It's crazy.
It's fun. That's funny. The zoysia grass didn't really take off, but the goosegrass sure did. Yeah, sometimes goosegrass can come in accidentally with sprigs of warm season grasses.
I know with some of those post-emergent herbicides, we really had much better luck with MSO than we did just with regular crop oils, it seemed like, especially when we were working with Drive, with quinclorac and things like that.
No, I'd like to do more work with those surfactants, non-ionic, MSO, crop oil concentrates. I just don't know, when you're doing small plot work like that, if you can get your applications accurate enough to see those subtle differences. I'd like to try, but the crop people tell me that it really does make a big difference. When the label specifies like something like methylated seed oil, it is definitely better than something like a non-ionic surfactant. Helena, incidentally, has some really interesting surfactants that they're working with, and they're combinations of several different things, and they look really interesting.
We had a number of turf managers struggling with field bindweed, and they would use the original formulation for Drive or quinclorac, and if they used crop oil, not much of effect, but if they used the MSO, it really had a big difference, it seemed like, with that, at least with field bindweed anyway.
Yeah.
So.
Well, we don't have any more questions that I see in here, but we'll still take some if people do have them, and we'll stick around till 12. But Brad, maybe you can put in the GCSA credits or the numbers again for today's session.
I did. I went ahead and posted those in the chat window. So today's, so there should be up above, you should have the previous GCSAA points, and then I just went ahead and posted today's 0.2 GCSAA points for that as well. So those should all be available there.
All right. Well, I think we'll end the conference. I want to thank everybody that showed up. I think we had between 80 and 95 people each day, which is great. And all the speakers, those that are here and those that aren't here but spoke this week. And hopefully we'll see everybody at an in-person conference soon. But if you have any feedback or comments on the format of this and whether you liked it, perhaps this is something we can continue in the future in addition to the in-person conferences that we do, just to supplement credits and stuff throughout the year. So, all right, everybody, thank you very much. Appreciate it.
Great. Thank you, everyone.